Hello, my dear students of class 9. Assalamu alaikum. I hope by the grace of Almighty Allah, all of you are well. Today, I want to discuss about your general mathematics, geometry part. So, geometry is the important part of mathematics. If you can understand geometry easily, then science is very easy for you. Without geometry, it is difficult for you. So, if you can understand this class easily, then I think that geometry part will be easy for you. Okay, let's go to our today class. Okay, my dear students, we can discuss about today topics. At first, you consider the following figure. First figure is wheel. Second figure is ball, and third is earth. Already, you can understand which topics we want to start today. Three figure like as round figure. And this object above are round C. Okay, that means today topics is chapter 8 and circle. Okay, my dear student, open your book and chapter 8. Circle is another important topics of geometry, and this part is called a Euclidean geometry. Why this is called a Euclidean geometry? Because the Greek mathematician Euclid first introduced this type of geometry, and that's why this geometry is called a Euclidean geometry. After this class, you will able to understand or define circle, diameter, what is radius, what is chord, tangent, and secant. Secondly, you will know about the angle at circle, angle at center, and third one is at the end of the class, last part of the class, and you can prove the two important theorem of this chapter 17 and 18. At first, our first discussion is what is circle. You consider this definition, the definition of circle. A circle is a geometrical figure. This is the geometrical figure, and with plane which are equidistant from the fixed point, and this fixed point is called the center of the circle. Okay. Just you see again the definition of the circle. A circle is a geometrical figure. This is a geometrical figure in a plane. That means in a plane it means that it is a two-dimensional. This the circle it must draw in surface space. Okay, not it is three-dimensional. That is why in a plane, which point are equidistant from the fixed point, and this fixed point is called the center of a circle. Okay. Go to our next topics. This is the circle and this is the center. From this center, all point of this circle are equidistant from this center. Okay. If you consider all point on this line, this is equidistant from the center O. Okay, this is the chord. Why this is chord? You can see next step, and this is radius and this is the diameter. Okay, now we can see our definition of these terms. Okay, first one is chord, second one is radius. This line is radius, and third one is diameter. This is called a diameter. And then tangent. This is called a tangent. Okay. Now consider these topics. At first, we want to know about the chord. What is chord of a circle? This is the important topics. Chord, the line segment connecting the two different points. The line segment connecting the two different points. If you this is the point and this is the another point. The joining line of these 2 points is called this is the chord of a circle. This is the chord of a circle. Okay, but joining the 2 points on circle is called a chord. Okay, my dear student, I think you can understand easily what is chord. And then diameter. Diameter is, this is called a diameter. This is called a diameter of a circle. This is the diameter of a circle. The chord passes through the center, it is known as a diameter. I think that diameter is also a chord of a circle, and diameter is the greatest chord of a circle because it is passing through the center. If any chord is passing through the center, this chord is known as a diameter. Its another name is a diameter, but diameter is also a chord. And what is radius now? What is radius? Radius is the half of diameter. That means half of diameter is called a radius. It is all easy for all. I think no need to further discussion. Okay. Now we want to discuss the important theorem of this exercise. My dear student, please attend this class because this is the important theorem. Okay. At first, we want to read the statement of this theorem. The line segment drawn from the center of a circle. The line segment, this is line segment OM, you can think, this is drawn from the center. To bisect a chord other than diameter is perpendicular of the chord. If a line segment is drawn from the center to any chord, but this chord not be a diameter, other than diameter, not diameter. Without diameter, other chord, for other chord this statement is true, but not for diameter chord. Okay. Just we can explain this theorem by this way. Just this is the center. This is a chord. This is AB. This is the chord is AB. If we can draw a line, bisector line, I think OM is the bisector line. It means that OM bisect the line AB. That means AM is equal to MB because OM is the bisector of AB. So OM is the bisector of AB. Then we have to prove OM is perpendicular on AB. It is our required statement. Then we have to prove this. Okay, how we can prove it? Okay, student, please, my dear student, attention this class. This is the particular enunciation. This is the particular enunciation. Please don't memorize this proposition because you can describe the proposition on your own language. Just think which is given. Given is OM as a bisector and AB is a chord. Just you can explain by this way. OM is the bisector of chord AB of a circle with center O. This is enough. No need to write the copy of your book. Just you can describe your own language. Okay, and it is required to prove OM is the perpendicular of AB. Okay, just OM is perpendicular on AB. You can write this language or this way mathematically. Join OA and OB. Okay, this is our drawing. At first, consider the triangle. Two triangles you can see in this figure. First one is OM and second one is OMB. Okay, just you can consider these two triangles. You can consider these two triangles, then you will get the congruence of triangle. What is the congruence of triangle? Just you have to prove the congruence of triangle. Consider OAM and OMB. How we can prove this as a congruent of two triangles? At first, this triangle and this triangle. At first, AM is equal to BM because both are equal, because OM is the bisector. OM is the bisector. Second one, OA and OB, both are radius of a circle, same circle, radius of same circle, and OM is equal to OM. This is the common side. Then it is, we can easy to say these two triangles are congruent. After the proof of congruence of two triangles, how we can say all sides, all angles are equal on two triangles. So this angle and this angle both are equal. OMA and OMB are equal. Okay, this is our proof after proving of the congruence of the two triangles. Then in this figure you can see, you can observe it easily OMA and OMB is equal to 180 degree because together two angles create a one straight angle. That's why 180 degree. And by using this OME is equal to OMB, if you replace OMB, if you replace OMB by OMA, that means OMA plus OMA is equal to 2 OMA is equal to 180 degree. Then OMA is equal to 90 degree. That means OMA is equal to 90 degree. If this angle is 90 degree, then what conclusion we can say? Because OM is perpendicular on AB. This is our proof. I think all student, you have understand this theorem. Okay. Now we can go to our next topics. Next topics is Theorem 18. It also important for you. All chords are of a circle. All chord of a circle, all equal chord. This is your given. My dear student, you have to know what is given and what statement we have to prove. This is important. At first you have to understand from your statement, otherwise it is difficult. If you want to memorize the theorem, then it is difficult for you. At first you have to understand all theorem and you have to all theorem statement understand easily, otherwise it is impossible to prove. And if you want to memorize any theorem, it is difficult for you. Okay, all equal chord. That means given condition is equal chord. If the two chord are equal, their distance from the center also be equal. So this is given and this is proved. Distance is, we have to prove their distance will be equal if the chord will be equal. That means AB and CD are two chord. Then we have to prove their distance from the center are equal. So how we can describe our proposition? Not you can describe, not follow this description. You can describe on your own language. Just you describe what is given. Given is two equal chord. A, B and C D are two equal chord. Okay. Of a circle with center O, and OE and OF are two perpendicular distance, and we have to prove their distance will be equal. That means OE and OF will be equal. Okay. Drawing, what is drawing? Just OA and OC have to join. Okay. And OE and OF are two perpendicular distance at first. In previous theorem, my dear student, what is the statement of previous theorem? If you can draw any perpendicular line on chord, then bisect this chord. Okay. Then OE and OF. OE is perpendicular on AB because this is perpendicular distance. Perpendicular, and OF also perpendicular. So OE is perpendicular on AB. Then what can we say? OE bisect AB. That means A is equal to B. A is equal to B. And if OF is perpendicular on CD, what we can say? So also bisect that chord. That means CF is equal to DF. Okay. So A is the half. We can say A is the half of AB. A is the half of AB because he is the midpoint, and CF is the half of CD. Okay. But this is our proof. If OE and OF are perpendicular on AB and CD respectively, then this is our proof. A is equal to half of AB and CF is equal to half of CD. Okay, but your given condition is AB is equal to CD. AB is equal to CD. Okay, if you multiply this line by half, multiply both sides by half, then what condition we can use? Half of AB is equal to A, half of CD is equal to CF. Okay, so A is equal to CF. This is the proof of second step. That means already we have proved AE and CF are equal. Now we want to consider the two triangle. These two triangle we want to consider. Then then we want to prove the congruence of two triangle. Okay, consider the two triangle, and you can write the two triangle. You can say OEO, AEO, OCF. You can say OAE and OCF. You can say anyway. Okay, this is our two triangle. How we can prove? This is the 90 degree. This also is a 90 degree. This is our construction. So OA is hypotenuse of this triangle, and OC is also hypotenuse of this triangle. So OA and OC are equal because why they are equal? Radius of same circle. They are both are radius and same circle in same circle. And A is equal to CF. This is our this step using step 2. In right angle triangle, we can say this is both triangle are congruent. This is RHS theorem of the right hypotenuse, right angle hypotenuse and side are equal. That means both triangle are congruent. If two triangles are congruent, which condition we can say their side OE and OF also be equal, because two triangles are congruent. If already we have proved two triangles are congruent, so it is easy to say OE is equal to OF. This is our proof, because OE and OF are two perpendicular distance from the center of the chord AB and CD respectively. So this is our proof, their distance are equal. Okay, this is complete of this proof. My dear student, I think if you can practice again and again in your home and attentively listen this class again in your home, then you can understand easily. And if otherwise, if you face any problem to understand this theorem, you can contact with your subject teacher. Okay. Today's homework is you have to repeat again in your home 17 and 18, and you have to submit your subject teacher. I think this is important theorem of circle. That's all about today's class.